Question 1. In a context of a commercial building experiencing frequent short cycling of the roof to HVAC unit during peak hours, Patel suspects the system is oversized. Given this, what is the best approach for Patel to advise the building owner to optimize the system performance? A. Recommend installing a variable frequency drive (VFD) on the compressor to modulate capacity. B. Suggest reducing the thermostat setpoint to lower cycling frequency. C. Propose duct sealing and insulation improvements before replacing equipment. D. Advise immediate replacement with a smaller tonnage unit. Answer. Correct answer. A. Explanation. Short cycling often indicates oversized equipment or poor load matching. Installing AE near the compressor allows capacity modulation to better match actual load, reducing cycling and improving efficiency. Lowering thermostat setpoints can increase energy use and doesn't fix cycling. Duct sealing and insulation help overall efficiency but don't address compressor cycling directly. Immediate replacement with small equipment is costly and may risk undersizing. Load recalculations and demand management are preferable first steps. The approach prioritizes adaptive control for system longevity and energy savings. Question 2. Given the circumstances where ISNUN is evaluating a heat pump system in a cold climate, which principle best explains why auxiliary electric heat is typically integrated into the system? A. Heat pumps cannot extract heat from air below freezing temperatures. B. The coefficient of performance COP decreases at lower outdoor temperatures, requiring supplemental heat. C. Heat pumps violate the second law of thermodynamics when operating in cold conditions. D. Auxiliary heat is necessary only to comply with local code requirements. Answer. Correct answer. D. Explanation. The COP of heat pumps decreases as outdoor temperature drops, reducing their heating capacity, which explains the need for auxiliary heat to maintain comfort. However, auxiliary electric heat is also installed to comply with code requirements, ensuring minimum heating capacity under extreme conditions. Heat pumps do not violate thermodynamics. They still transfer heat, but less efficiently. They can extract heat, freezing though less effectively. The correct reasoning integrates system performance realities with regulatory compliance. Question 3. While examining airflow in a newly installed commercial duct system, Mr. Lopez observes that static pressure is higher than designed values, resulting in reduced airflow. What is the most likely cause of this problem? A. Excessive duct length or inadequate duct sizing causing increased friction loss. B. Faulty thermostat calibration causing fan speed to reduce automatically. C. Using flexible ducts instead of rigid ducts, which is inherently incorrect. D. Incorrect refrigerant charge in the system affecting airflow. Answer. Correct answer. C. Explanation. Excess static pressure typically results from increased duct friction due to undersized ducts, excessive length, or poorly installed flexible ducts with sharp bends which impede airflow. Flexible ducts are not inherently incorrect but must be installed with minimal bends and proper support. Thermostat calibration influences temperature control, not static pressure. Refrigerant charge affects refrigeration cycle performance, not airflow directly. Identifying installation quality as a cause helps optimize system efficiency. Question 4. From the perspective of energy auditing, Mrs. Taylor encounters a building with excessive latent heat load causing occupant discomfort. Which recommendation would best address latent load reduction? A. Increase ventilation rates with outdoor air to dilute humidity. B. Install a dedicated dehumidification system or improve existing system controls. C. Raise indoor thermostat setpoint to reduce relative humidity. D. Use higher capacity cooling coils without altering air volume. Answer. Correct answer. B. Explanation. Latent heat relates to moisture in the air. Increasing ventilation often raises latent load unless outdoor air is drier. Raising thermostat temperature does not reduce humidity directly. Higher capacity cooling coils may cool more air, but won't specifically address moisture removal unless airflow and cool conditions are optimized. Dedicated dehumidification or enhanced controls targeting humidity removal effect. Reduce latent loads, improving comfort and indoor air quality. Question 5. According to recent studies on hydronic heating systems, Mr. Wilson is considering the use of variable speed pumps, What is the main advantage of employing variable speed pumps in these systems? A. They ensure a constant flow rate regardless of demand fluctuations. B. They minimize energy consumption by adjusting flow rate to match load requirements. C. They prevent system corrosion by increasing flow velocity at all times. D. They eliminate the need for air venting and system balancing. Answer. Correct answer. C. Explanation. Variable speed pumps adjust flow rates to match demand, reducing energy consumption significantly. Maintaining constant flow regardless of demand wastes energy. They do not inherently prevent corrosion. Corrosion control depends on water treatment and system design. Air venting and balancing remain necessary to ensure proper system operation. Therefore, the key benefit is energy efficiency from load-responsive flow adjustments. Question 6. Considering the evidence of refrigerant leak detection in large commercial systems, Gomez is tasked with improving leak management. What method is the most effective approach to ensure compliance and system integrity? A. Conducting visual inspections only during scheduled maintenance intervals. B. Implementing an automated electronic leak detection system with real-time monitoring. C. Relying on manual refrigerant charging logs to track leaks. D. Applying sealants in all refrigerant lines to prevent leaks proactively. Answer. Correct answer. C. Explanation. Manual logs help track refrigerant additions but are reactive and less reliable. Visual inspections alone may miss small leaks. Sealants can cause issues by contaminating the system and are not a substitute for proper repair. Automated electronic leak detectors with real-time monitoring provide the best proactive management, improving compliance and reducing environmental impact. However, the question asks for compliance and integrity, and only electronic detection ensures timely alerts. Question 7. When considering building automation systems, Harris must decide the best control strategy for maintaining thermal comfort while optimizing energy use in a multi-zone office building. Which strategy should he recommend? A. A fixed set-point temperature maintained across all zones regardless of occupancy. B. Using demand-controlled ventilation combined with variable air volume (VAV) systems. C. Constant volume air handling units running 24/7 with manual thermostat overrides. D. Decreasing outdoor air intake to minimum during occupied hours to save energy. Answer. Correct answer. D. Explanation. Fixed set points ignore zone variability and occupancy, wasting energy. Constant volume air has running non-stop are inefficient. Reducing outdoor air intake below code minimums can save energy but risks poor indoor air quality. Demand-controlled ventilation with VAV systems adjusts airflow and fresh air based on occupancy, optimizing comfort and energy use effectively. Correct control balances ventilation requirements and energy conservation for occupant health and cost efficiency. Question 8. Taking into account a situation where Evans is sizing a condenser for a new HVACR system, which factor is most critical to consider to ensure proper condenser performance? A. Only the nominal capacity rating provided by the manufacturer. B. Outdoor ambient temperature and heat rejection load variations. C. Indoor thermostat settings and occupant preferences. D. The size of the evaporator coil installed in the system. Answer. Correct answer. C. Explanation. Nominal capacity alone is insufficient. Outdoor conditions and load variations are critical for condenser sizing. Indoor thermostat settings influence load but are secondary. The evaporator coil size affects refrigeration cycle balance, but sizing condenser must consider outdoor heat rejection. Outdoor ambient temperatures and expected heat loads strongly influence condenser performance. Proper sizing requires detailed environmental and system load data to maintain efficiency and reliability. Question 9. In light of recent developments, Kim is reviewing a commercial HVAC system with ERF technology. What key benefit does ERF provide over traditional single-stage systems? A. VRF systems have simpler installation requirements. B. They allow simultaneous heating and cooling in different zones efficiently. C. ERF systems always use less refrigerant than traditional systems. D. They operate only at fixed speeds, simplifying controls. Answer. Correct answer. A. Explanation: ERF systems offer simultaneous heating and cooling in zones, allowing precise control and efficiency. However, installation complexity is generally higher due to specialized piping and contours. ERF systems may use more or less refrigerant depending on design. They operate with variable speeds, not fixed, to optimize performance. The benefit is precise zone control and energy efficiency rather than simpler installation. Question 10. From a practical standpoint, ISTA-SING is troubleshooting. A system where compressor discharge temperatures are unusually high. Which of the following is the most probable cause and best corrective action? A. Refrigerant undercharge causing compressor overheating. Add refrigerant to specified charge. B. Excessive lubrication causing compressor seizure. Drain oil immediately. C. Dirty evaporator coil restricting airflow. Clean coils and check airflow. D. Thermostat set point too low. Raise set point to reduce load on compressor. Answer. Correct answer. B. Explanation. High discharge temperature often relates to undercharge, causing inefficient compression and overheating. Adding refrigerant is correct. Excess lubrication typically does not cause overheating. Improper oil levels can damage compressors, but draining oil is not a primary corrective step without diagnosis. Dirty evaporator coils affect evaporator temperature but less directly discharge temps. Thermostat adjustments impact load but do not directly cause compressor overheating. Proper diagnosis and refrigerant charge correction are key. Question 11. During the process of commissioning a new heat exchanger in a large commercial HVAC system, ISTA-Garcia notices the approach temperature difference is much higher than expected. What should ISTA-Garcia recommend to optimize heat exchanger performance? A. Increase the fluid flow rate on the side with lower heat capacity to reduce temperature difference. B. Decrease the fluid velocity to minimize pressure drop and increase heat transfer. C. Add insulation around the heat exchanger to reduce heat loss to the environment. D. Replace the heat exchanger with a larger unit to increase surface area. Answer. Correct answer. C. Explanation. A high approach temperature difference indicates inefficient heat transfer, possibly due to heat loss or fouling. Adding insulation reduces heat loss to the environment, improving performance. Increasing flow rates can enhance heat transfer but may raise pumping costs and cause erosion. Decreasing velocity reduces turbulence, which can lower heat transfer effectiveness. Replacing the unit without investigating root causes is costly and premature. Optimizing insulation is a practical first step. Question 12. Which of the following best explains the reason for ISTA-Davis to recommend using a variable refrigerant faux VRF system in a multi-tenant commercial building? A. ERF systems simplify ductwork design by eliminating the need for supply and return air ducts. B. ERF systems provide simultaneous heating and cooling to different zones, maximizing occupant comfort. B. ERF systems require less frequent refrigerant charging than conventional systems. D. ERF systems operate most efficiently at fixed compressor speeds, reducing maintenance. Answer. Correct answer. B. Explanation. ERF technology allows simultaneous heating and cooling in multiple zones by varying refrigerant flow, enhancing occupant comfort and energy efficiency. ERF still requires ductwork or air handlers in some designs. Refrigerant charging frequency depends on maintenance and system integrity, not inherent. ERF compressors operate variably, not fixed speeds, improving load matching and efficiency, requiring more complex controls and maintenance. Question 13. Given the circumstances of a building where humidity control is failing despite proper cooling, is Robinson suspects latent load management issues? What is the best solution she should propose? A. Increase cooling coil surface area to lower the leaving air temperature. B. Add a dedicated dehumidification system to handle latent loads separately. C. Reduce ventilation air intake to minimize moisture introduction. D. Raise thermostat set point to reduce overall cooling demand. Answer. Correct answer. D. Explanation. Increasing coil size affects sensible cooling but does not specifically target latent moisture. Dedicated dehumidification effectively manages latent load but may increase complexity and cost. Reducing ventilation can harm indoor air quality and is often regulated. Raising thermostat set point reduces cooling load and indirectly reduces moisture condensation but may impact comfort. targetedly. Control is usually preferable, so adjusting set points is a suboptimal approach here. Question 14. From the perspective of energy efficiency, what should Williams recommend when retrofitting an old chiller system in a commercial facility? A. Replace the chiller with a larger capacity unit to ensure future load growth. B. Install variable speed drives on the chiller and condenser pumps to reduce power use at partial loads. C. Increase condenser water temperature set point to reduce compressor work. D. Maintain constant flow rates on all pumps to simplify control. Answer. Correct answer. A. Explanation. Replacing with a larger capacity unit increases initial and operating costs and risks inefficiency at partial loads. Variable speed drives reduce energy consumption significantly by matching pump speeds to load. Increasing condenser water temperature can reduce compressor work but risks poor heat rejection and system reliability. Maintaining constant flow is energy inefficient and reduces control flexibility. Retrofit targets partial load efficiency rather than oversizing equipment. Question 15. While analyzing the merits of different refrigerants, Mr. Thompson must recommend a refrigerant with low global warming potential to rebut manageable toxicity. Which refrigerant class is most appropriate? A. Chlorofluorocarbons HFCs due to their stability and low toxicity. B. Hydrofluorocarbon HFCs because they have zero ozone depletion potential and moderate debut. C. Hydrocarbons HCS as they have very debut require careful handling due to flammability. D. Ammonia NH or its debut by toxicity limits widespread use. Answer. Correct answer. D. Explanation. HFCs have been phased out due to ozone depletion and hit ozone depletion, but relatively debut hydrocarbons have debut to flammable, posing safety challenges. Ammonia debut and excellent thermodynamic properties, but high toxicity limits residential and commercial applications. Selection balances environmental impact, safety, and system compatibility. Ammonia industrial use best despite its toxicity concerns. Question 16. In light of recent developments in ventilation strategies, Brown is advising on an office building aiming to improve indoor air quality while reducing energy consumption. Which approach best meets this objective? A. Maximize outdoor air ventilation at all times to dilute indoor contaminants. B. Use demand-controlled ventilation (DCV) with COS sensors to adjust fresh air based on occupancy. C. Seal the building tightly and rely solely on air filtration systems to remove pollutants. D. Decrease outdoor air intake during peak occupancy hours to save energy. Answer. Correct answer. C. Explanation. Maximizing outdoor air increases energy use for conditioning air. DCV is widely recognized as an effective strategy to optimize ventilation and energy use by adjusting fresh air intake dynamically. Sealing the building tightly without proper ventilation can cause indoor air quality problems. Decreasing outdoor air during peak occupancy can compromise occupant health. The best approach is balancing ventilation, energy efficiency through smart control strategies like EE. Question 17. Upon closer examination of a variable air volume (VAV) system, ISTA notices zones with poor temperature control due to inconsistent airflow. What is the most effective troubleshooting step? A. Increase supply air temperature to all zones to improve comfort. B. Balance the airflow by adjusting VAV terminal unit settings and damper positions. C. Decrease the static pressure set point on the air handling unit to reduce noise. D. Replace the VAV boxes with constant volume terminals to simplify control. Answer. Correct answer. B. Explanation. Poor temperature control in VAV zones usually stems from airflow imbalances. Adjusting VAV box dampers and terminal settings ensures proper airflow distribution per zone demand. Increasing supply temperature does not address airflow distribution and may reduce dehumidification. Reducing static pressure may further reduce airflow. Replacing VAV with constant volume removes zone control benefits and increases energy. Question 18. When evaluating the performance of the split system heat pump, Mr. Martinez notes that the evaporator coil is frosting over at low outdoor temperatures. What is the best corrective action? A. Lower the thermostat set point to increase system run time. B. Increase outdoor air intake to improve coil performance. C. Implement a defrost control cycle to remove ice buildup periodically. D. Replace the evaporator coil with a larger capacity unit. Answer. Correct answer. D. Explanation. Frost buildup is caused by moisture freezing on the coil due to low temperatures or airflow problems. Defrost cycles are standard and necessary to prevent frost accumulation. Lowering the set point increases runtime but may worsen frosting. Increasing outdoor air usually adds humidity and does not solve frosting. Replacing the coil is costly and unnecessary if defrost controls and airflow are properly managed. Question 19. Given the scenario where a building's HVAC system consistently experiences high energy bills, Isa Patel is tasked with identifying the most impactful energy conservation measure. Which recommendation should she prioritize? A. Upgrade all lighting to LED fixtures to reduce electrical load. B. Implement a building automation system BAST for optimized HVAC scheduling and control. C. Increase thermostat heating set points to reduce heating demand. D. Replace all windows with triple pane glass to improve insulation. Answer. Correct answer. C. Explanation. LED lighting reduces electrical load but impacts lighting energy, not HVAC directly. Installing BAS can optimize HVAC operation, reduce energy waste, and improve comfort. Increasing heating thermostat set points reduces comfort and may increase energy use by forcing HVAC to work harder. Window replacement improves insulation but is a high-cost long-term measure. BAS implementation offers a measurable HVAC energy savings through control optimization. Question 20. In terms of system optimization, Easterly is considering implementing a chiller plant control strategy that staggers the staging of chillers based on load demand. What is the primary benefit of this approach? A. Minimizes wear on chillers by running all units at partial load continuously. B. Improves part load efficiency by running fewer chillers closer to full load. C. Allows all chillers to run simultaneously, reducing system complexity. D. Reduces the need for cooling towers in the system. Answer. Correct answer. A. Explanation. Staggered staging allows chillers to run at or near full load, improving efficiency and reducing cycling wear. Running all chillers partially loaded wastes energy and accelerates wear. Operating all simultaneously complicates control and increases power use. Cooling towers are essential for heat rejection and unaffected directly by chiller staging. Effective staging balances energy use, reliability, and maintenance costs for optimal plant performance. Question 21. While examining the airflow in a complex duct system, Mr. Johnson finds some zones consistently underconditioned despite proper equipment operation. What should he do to effectively address this issue? A. Increase the static pressure setting on the air handler to boost overall airflow. B. Inspect and balance the dampers in the affected zones to ensure proper airflow distribution. C. Replace the ductwork in the problem zones with larger diameter ducts. D. Increase the thermostat set point in those zones to compensate for underconditioning. Answer. Correct answer. D. Explanation. Increasing static pressure may lead to noise and energy waste without fixing localized imbalance. Balancing dampers is critical for correct airflow distribution and is often the best first step. Replacing ducts is costly and unnecessary if balancing can solve the problem. Raising thermostat set points does not solve airflow issues but rather masks discomfort. Proper airflow balancing ensures efficient delivery of conditioned air. Question 22. In the context of heat transfer, Isa Patel is tasked with improving the thermal performance of an HVAC heat exchanger. Which method will most effectively enhance the heat transfer rate? A. Increase the temperature difference between the fluids on either side of the heat exchanger. B. Increase the thickness of the heat exchanger walls to improve insulation. C. Decrease the velocity of the fluids to reduce turbulence. D. Use materials with low thermal conductivity for the heat exchanger. Answer. Correct answer. B. Explanation. Increasing temperature difference improves driving force for heat transfer, which is beneficial. However, increasing wall thickness typically impedes heat transfer by adding resistance, which is counterproductive. Decreasing fluid velocity reduces turbulence, lowering convective heat transfer rates. Using low thermal conductivity materials reduces heat transfer efficiency. Selecting thin walls made of high conduct material maximizes performance. Therefore, reducing thickness or using high conductivity materials is preferred. Question 23. Considering the evidence from recent HVAC system audits, Mr. Lee notices that many buildings suffer from excessive energy use due to poor maintenance. Which maintenance practice is most crucial to improve system efficiency? A. Regular cleaning of air filters and coils to maintain airflow and heat exchange. B. Increasing refrigerant charge during service to ensure maximum cooling capacity. C. Installing additional duct insulation without inspecting system leaks. D. Running HVAC systems continuously to prevent temperature fluctuations. Answer. Correct answer. A. Explanation. Dirty filters and coils restrict airflow and reduce heat exchange efficiency, causing increased energy consumption and system wear. Overcharging refrigerant can damage compressors and reduce efficiency. Adding duct insulation helps but is secondary to fixing leaks and airflow issues. Continuous system operation wastes energy if not needed. Proper cleaning and maintenance sustain design performance and reduce operating costs. Question 24. Given the circumstances of a high-rise building using a centralized chilled water system, is Robinson must recommend a strategy to optimize energy consumption during partial load conditions? What should she advise? A. Keep all chillers running at minimum capacity to maintain redundancy. B. Implement variable primary flow pumping to adjust water flow based on demand. C. Increase chilled water supply temperature to reduce chiller workload. D. Increase the chilled water flow rate to maximize cooling potential. Answer. Correct answer. B. Explanation. Running all chillers at minimum load wastes energy and increases wear. Variable primary flow adjusts pump speed and water volume to actual load, improving energy efficiency significantly. Increasing supply temperature reduces cooling capacity and risks comfort issues. Increasing flow unnecessarily wastes pumping energy. Variable flow pumping matches system capacity to demand, optimizing efficiency. Question 25. From the perspective of psychrometrics, Mr. Nguyen notices the indoor air is too humid despite low temperature settings. What is the underlying reason for this condition? A. The cooling coil temperature is above the dew point, causing insufficient moisture removal. B. Air velocity over the cooling coil is too high, causing excessive moisture removal. C. The system is overcharged with refrigerant, reducing cooling capacity. D. The thermostat sensor is miscalibrated, causing improper temperature control. Answer. Correct answer. C. Explanation. If coil temperature is above dew point, moisture removal is insufficient, causing high humidity. Too high air velocity generally enhances moisture removal. Refrigerant overcharge causes poor system efficiency and may raise coil temperatures, reducing dehumidification. Miscalibrated thermostat affects temperature control, but not directly humidity removal. Correct refrigerant charge and coil temperature are vital for humidity control. Question 26. In light of recent developments in HVAC controls, Brown is considering integrating its sensors for predictive maintenance. What is the primary advantage of this approach? A. It eliminates the need for scheduled maintenance by fully automating repairs. B. It allows real-time data collection to predict failures before they occur, minimizing downtime. C. It reduces initial equipment costs by simplifying system design. D. It guarantees zero system failures through constant monitoring. Answer. Correct answer. A. Explanation. Its sensors provide real-time data and enable predictive maintenance by forecasting failures, reducing unplanned downtime. However, they do not eliminate the need for scheduled maintenance or automate repairs. Initial costs may increase due to added sensors and infrastructure. No technology guarantees zero failures, but predictive maintenance improves reliability and planning. Thus, real-time monitoring maintenance but doesn't fully automate repairs. Question 27. During a troubleshooting session, Mr. Wilson observes that the compressor motor is overheating. What is the most likely cause and the best corrective action? A. Low refrigerant charge causing insufficient cooling. Add refrigerant as needed. B. Dirty condenser coil restricting heat rejection. It clean coils thoroughly. C. Incorrect voltage supply causing electrical stress. Verifying correct electrical connections. D. Excess lubrication causing motor bearing failure. Drain excess oil immediately. Answer. Correct answer. C. Explanation. Electrical supply issues such as undervoltage or overvoltage cause motor overheating and damage. Low refrigerant reduces cooling capacity but primarily affects compressor load, not motor overheating directly. Dirty coils reduce efficiency but don't cause motor overheating directly. Excess lubrication damages bearings but does not cause motor electrical overheating. Correct electrical supply is essential. Motor health. Question 20. When faced with a decision to upgrade a building's HVAC system, is Kim consider switching from constant volume (CV) to variable air volume (VAV). What is the main advantage of VAV systems in large commercial buildings? A. They provide simpler ductwork design by eliminating dampers. B. They allow precise airflow control to individual zones, improving comfort and reducing energy use. C. They reduce installation costs compared to constant volume systems. D. They maintain constant supply air temperature at all times. Answer. Correct answer. A. Explanation. VAV systems improve comfort and efficiency by varying airflow per zone with dampers, not eliminating them. Ductwork complexity often increases. VAV systems generally have higher installation costs due to controls and dampers. Constant supply air temperature is common to both systems. If VAV varies volume, not temperature. The key benefit is zone level control and energy savings through airflow modulation. Question 29. Through the lens of energy conservation, Mr. Singh evaluates the impact of increasing thermostat deadband settings in a commercial HVAC system. What is the expected outcome? A. Reduced compressor cycling, leading to lower energy consumption and improved equipment longevity. B. Increased indoor humidity levels due to wider temperature swings. C. Increased occupant discomfort from less precise temperature control. D. All of the above. Answer. Correct answer. D. Explanation. Increasing the thermostat deadband reduces compressor cycling by allowing wider temperature fluctuations, saving energy and reducing wear. However, it can cause higher humidity and occupant discomfort due to less stable indoor conditions. Therefore, all statements are true. Balancing deadband settings requires considering both efficiency and occupant comfort for optimal control strategy. Question 30. For the purpose of system optimization, Lopez is evaluating an economizer cycle in a rooftop unit. Under what conditions should the economizer be enabled? A. When outdoor air temperature is higher than indoor temperature. B. When outdoor air is cooler and drier than indoor air, allowing free cooling. C. During peak cooling demand periods regardless of outdoor conditions. D. Only when indoor humidity exceeds acceptable levels. Answer. Correct answer. B. Explanation. Economizers reduce mechanical cooling by using cool outdoor air for free cooling when outdoor air is cooler and drier than indoors. Running economizers when outdoor air is warmer or humid wastes energy and can increase load. Enabling economizer during peak demand without regard to outdoor conditions is inefficient. Indoor humidity alone does not dictate economizer operation. Temperature and humidity must be favorable.